With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Dear students, question is, structure of ascorbic acid is represented as follows. This is our ascorbic acid, vitamin C. Now question is, how many of the following reagents can give positive test with ascorbic acid? Now these reagents given are cuprous chloride ammonium hydroxide 2,4-DNP, sodium metal HCl and zinc chloride, ferric chloride, sodium hydroxide and phenolphthalein, dilute KMnO4, bromine water, silver nitrate and ammonium hydroxide, iodine and sodium hydroxide. Now let us see, ascorbic acid will give reaction with what type of reagents. Now before going to that, let us see the nature or different types of functional groups or bonds present in double bond, single bond, etc. present in ascorbic acid. Now ascorbic acid, if we carefully see, it is in an ene-diol structure. Ascorbic acid is having ene-diol structure. Here this is ene-diol structure, this is ene-diol structure, that is phenolic OH. That's why the OH, these two OH becomes phenolic. These two OH becomes phenolic. So this gives its acidic nature. This ene-diol structure gives it acidic nature because it is not having any COH group. No carboxylic group is present, but still it is called an acid because of due to these two phenolic OH groups. So phenolic OH group is this group. If a carbon double bond is OH is attached to such carbon-carbon double bond, then we will say this is phenolic OH group. Then next point is, it is conjugated with the carbonyl group, conjugated with the ene-diol is conjugated with carbonyl group. ene-diol structure conjugated with carbonyl group. Then enolic hydrogen atoms give it acidic quality, these enolic. And apart from that, it is having two alcoholic OH groups. Here they give alcoholic character to this ascorbic acid. So two alcoholic OH groups. So, and it is having a double bond also, multiple bond, carbon-carbon, multiple bond. One carbon-carbon, multiple bond. Now, seeing this structure, we can know which reagent, with which reagents it can react. So, it does not react with cuprous chloride and ammonium hydroxide. It will give tetramine copper chloride mixture, that is cuprous chloride and ammonium hydroxide, and that does not react with our ascorbic acid. Now it won't give react with 2,4-DNP because carbonyl compounds only will react with 2,4-DNP, but it is not having a free carbonyl group, is not here. This carbonyl group is associated with oxygen, that is, this forms a ester structure, ester-like structure. Therefore, it is a lactone. Therefore, there is no free CO group. Since no free CO group, therefore no reaction with 2,4-DNP. 2,4-DNP, dinitrophenyl hydrazine. Then with sodium metal, because it is having phenolic OH groups, therefore it reacts with sodium metal to give sodium phenoxides. So ascorbic acid, we know I am writing only this part, the required part, OH and OH. This reacts with sodium metal liberating hydrogen, O minus Na plus, O minus Na plus hydrogen. Therefore reacts with sodium metal. Then next is HCl and zinc chloride. It is, you know Lucas reagent, and Lucas reagent is for alcohols. So here this is primary and this is secondary, and both react with alcohols. This OH will not react, but only secondary alcohol OH group is that this will react with HCl and zinc chloride. Therefore, it reacts with zinc chloride to form alkyl halide. Then with ferric chloride, neutral ferric chloride, because it is having phenolic OH groups, it will react with ferric chloride to form a complex. Phenolic compounds form a complex. Phenolic compounds form a complex with neutral ferric chloride. Fe. The required portion only I am drawing. Very structure. So 3 minus plus 6H plus 3 Cl minus. So that's why it reacts with ferric chloride solution to form a violet colored complex. Since it is acid, it reacts with sodium hydroxide with phenolphthalein. That means it discharges the pink color of phenolphthalein. Then comes dilute KMnO4. It also reacts with dilute KMnO4 because it is having a double bond. So it reacts with dilute KMnO4. Reacts with dilute KMnO4. Reacts with dilute KMnO4 to form, because dilute KMnO4 is an oxidizing agent, dilute KMnO4. So it breaks the double bond plus to form a dicarboxylic acid. Then the next one is bromine water. Bromine water also it will react. It won't react with the tolerance reagent because it is not a aldehyde. You know tolerance reagent silver nitrate and ammonium hydroxide. They react with aldehydes because aldehydes can easily be oxidized to acids. So it is not a aldehyde, therefore it won't react. Then iodine and sodium hydroxide. This is our haloform reaction reagent, and this haloform reaction happens when there is CH3CO group. So since there is no CH3CO group, it won't react. Therefore only with bromine and hydrogen, water also, it will react due to the presence of double bond. So therefore here, since we are having a double bond here, it reacts with bromine water to form a dibromo product. Therefore, with how many reactors? Now we'll see, we'll sum them up. With how many reagents? It is reacting 1, 2, 3, 4, 5, 6. Therefore, total 6 reagents with which ascorbic acid reacts in the given question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.